Okay, so speed is a ratio of distance to time. And so in this case, we're going to say it's distance over time. And that's how the ratio looks. Now, what is time going to be measured in? Yes?
Hours.
Ooh. Seconds. So base unit for distance is meters. Base unit for time is seconds. So meters per second. That's going to be our normal thing. So when I said earlier how I want you to do the formula, that's how I want you to do it. You should do it S equals d over t. And that's how you do it. And that's always going to be meters over second. Speed's in meters per second. Yep.
What is the difference between velocity and speed?
We'll get to velocity after speed.
Isn't the same thing? What was?
No.
We'll get to that. Alright. So, speed. We're okay with that? Yes?
Yes.
Alright. So, the trouble is, if it's a ratio, you can certainly graph it. Distance over time. D is going to be on the y, and time is going to be on the x, because your question is distance per time. So, if you, say, have a graph like this, and we could label this point A, and B, and C, and this one is 1, 2, 3, 4. I'm going to ask you some questions about this. There are three main kinds of speed. Alright? One speed is called instantaneous. Instantaneous. What is instantaneous speed?
At the moment.
At that moment, right at that moment. So, if you were to compare the instantaneous speed of A to B, which one has a greater instantaneous speed?
A.
A, how do you know?
Because I guessed. Oh no, because A is moving up in time.
Right. So you can actually see that, sure enough, over time through A, you're actually going a distance. You went that far in this amount of time. Right? It's got an angle. Whereas here, at B, your distance isn't changing at all over time. You're going nowhere, you're just sitting there. So sure enough, instantaneous speed of A is greater than B. What about A to C?
Oh.
Yes?
It's still like this is this one.
It's still A, and you can take a look at that angle here. The angle here is much greater than this angle here. So sure enough, the incline is greater, and you're covering greater distance in the same amount of time as you are in C. So that's instantaneous speed. Yes? So let's try another one. Another one is called constant speed. So, where do we have constant speed? When it does what? When it does a straight line. So we have constant speed here in three different sections. From 1 to 2 is constant, from 2 to 3 is constant, from 3 to 4 is constant. It's a straight line. What would speed look like if it was not constant? What would it look like? It looked like a squiggly line, so it would be a curvy line. It's always changing. It's either speeding up or slowing down, or speeding up or slowing down. Right? That's where you'd be going more for the instantaneous speed. So this here is not constant. And the third one is average speed. How do you find average speed? Yes, sir.
You take the average of the times. Well, say you make a.
Well, if speed is distance over time, what is average speed?
The averages of the distances over the time.
Close, Bishop.
Time over distance.
Reverse that.
Distance over time.
Exactly. So average speed is going to be the total distance over the total time. Right? So in this case, you take a look at it, and you say, okay, we know that we went this far. So here's our total distance, and we took this long to do it. So here's our total time. So total distance over total time is going to give us our average speed, and on the graph, that's going to look like what?
It's going to look like a line from 1 to 4.
Yeah, so it's going to look like this line. And that's called also the line of best fit. You usually take the average.
Wait, the line of best.
You've heard that before, right? Line of best fit?
I think it's
You graph it.
like on Logic Pro.
Yeah, Logger Pro will give you the
Did we do
actual
this last
average speed.
during astronomy?
You might have.
Or astronomy?
Okay, let's try another one. So let's do an example. You guys ready?
Sure.
Yes.
All right. So
No
let's say,
Indiana.
let's say Mr. Shoes starts in Indianapolis. And
Artistic genius!
yes, artistic genius. Good call. So Mr. Shoes travels north, let's say for
5 miles.
100 miles.
Oh, snap.
And he does that in, let's say, no, wait, so let's say 200 miles. And then he goes east for 200 miles. And then he goes south for 100 miles. And then he goes west for 200 miles.
This Mr. Shoes has no life.
Hey now, I'm a courier. I'm carrying things from here to there. So, the question is, what is Mr. Shoes' distance? What is Mr. Shoes' displacement? And average speed. Let's say it takes me 1, 2, 3, 4, 5, 6 hours to do all that. So, what's Mr. Shoes' distance?
600 miles.
Why did I figure that out?
Because I added.
So 200 plus 200 plus 100 plus 100, that's 600 miles? What is his displacement?
0 degrees 0.
0
100 miles an hour. That's,
miles? And average speed is?
100 miles per hour.
100 miles per hour.
that's really fast.
The cops
Yeah. Let's just say I have good radar.
Did you get a ticket? No, he rode his flying cow.
That's right. The one that jumped over the moon. Don't you remember that one? You ever wonder what happened to that cow? It's in my house. Okay. So, okay, so we're okay with that? Now, what on the other hand, what if Mr. Shoes started off in Indianapolis, and he's going to Chicago, that's 250 miles away, and it takes Mr. Shoes 3 hours to get there. The question is, what is the time? And Mr. Shoes says you should use the formula. So if you know you're solving for time, you should really solve for time and say that's distance divided by speed. So tell me, how much time will it take to get to Chicago? Yes.
Well, it would be 250
250 miles over. Oh wait, we're not solving for time, are we? I just gave you time.
Yeah.
What are we solving for?
Speed.
Speed.
250 over 3.
83.3333333.
So that's going to be 250 miles over 3 hours.
83.333.
83 miles per hour. Right?
So you have to convert it.
Did we? We didn't have to convert anything, did we?
Very
Very good. Now, if we were going to turn this into displacement, what would the displacement be?
What?
Yes? 250 miles northwest. Very good. Okay, so let's try another one. Let's go for velocity. Mr. Bishop asked about velocity. Velocity is exactly the same thing as speed, and for most of the world, that's where it stops. His velocity was such and such miles per hour. His velocity was such and such meters per second. Well, velocity doesn't stop there. It also is a vector, which means it has what?
Quantity and
it has and direction. So speed and direction. So velocity has speed and direction. So if you hear velocity in movies, or in the news, or in your magazines, or wherever, it doesn't have direction, it's not velocity. Alright, so that's where you run into trouble. Okay, so it is a vector. And as such, you can combine velocities. So, let's take Mr. Shoes. And Mr. Shoes is walking.
Is he from Minecraft?
Mr. Shoes is walking at 4 meters per second towards the airport. So here's my question. If Mr. Shoes is walking 4 meters per second towards the airport, I'm walking.
You're flying
2 meters walk.
4 meters.
Then, what is Mr. Shoes' velocity?
You're walking.
How far is the
Yes.
airport?
4 meters per second, wherever direction the airport.
towards the airport, right? Now, on the other hand, we all know the fancy lights in the ceiling. Right underneath there is this moving walkway. You're coming to the end of the moving walkway.
Oh, the moving walkway is coming to an end. Please watch your step.
Let's say this moving walkway is moving at 4 meters per second. Now, what is Mr. Shoe's new velocity?
8 meters per second.
No.
16 meters per
second.
No.
8 meters per second. 8 meters
Already
per
said
2
that.
No.
seconds.
16 meters per second.
8 meters per 2 seconds.
So we have 4 meters per second plus 4 meters per second,
8 meters per 2 seconds.
and that's going to give us
4 meters per second.
8 meters per second toward the airport.
Oh,
Don't forget, when you say 8 meters per second, you need a direction to make it a velocity. So you can combine velocities. What if, on the other hand, Mr. Schuth runs into a troublesome walkway?
That's not fair.
Instead of helping Mr. Schuth, it is hindering Mr. Schuth.
2 miles a second towards the airport.
2 meters per second. 2 miles a second.
Then what do we have?
2 meters per second towards the airport.
Okay, so then we're going to get 2 meters per second towards the airport. So you can add velocity.
Why'd you put a plus sign?
What? Because we're adding them.
You're you're adding the negative.
So 4 meters per second that way, 2 meters per second that way, and you end up with 2 meters per second that way.
Hey.
Okay, let's try another one. Ready? What? Yes, the moving walkway is coming to an end. The moving. That's fine. You guys are good at that. So let's try another one. Mr. Schuth instead. Notice we have a moving walkway this way. Yes. 4 kilometers per second, and Mr. Schuth is.
That's amazing.
Mr. Schuth straps on his rollerblades.
Oh my god. And you're moving at 1,000 kilometers
Oh.
per second.
Mr. Schuth ran out. He ran out of room there. And let's say he's doing 8 meters per second that way, right?
4 kilometers a second.
Now, what is Mr. Schuth's velocity as he crosses this moving walkway? Yes.
Okay, so, well, since you're going 8 meters per second, and the moving walkway is going 4,000 meters per second.
4 kilometers. Oops.
That's
Let's keep the units the same. Let's keep the units the same just for simplicity's sake.
1,008.
Okay, so 4 meters per second.
Nope.
You said kilometers.
I did it again, didn't I?
4 meters per second that way.
Yeah.
So then it would be 4 meters per second going this way, but then you would be going down a little bit, so it'd be kind of like that.
12 meters
Going
per
diagonal.
second going southeast.
So you have to figure it out. So if it's this plus this, we're gonna end up with
Google Plus.
something like that, right?
It's a triangle.
So how do we figure that out?
Not anything.
Aha. We have to go back to C equals
MT
A squared plus B squared and square root of that.
Wouldn't it be awesome if moving walkways did move at 4 kilometers per second?
That would be cool. You get places fast. So what's the answer here?
8.9.
8.9?
Jump on it, to keep yourself from being torn into pieces.
It's like the moving
Okay.
walkway.
So that equals
No, seriously, dude. When you're about 20 feet away,
Okay.
you have to jump up.
alright, doll, I'm ready.
Hello.
So 8.94 meters per second in this direction. So notice it's a velocity. You can combine velocities. You can combine negative velocities. It's all about direction. And with your resultant answer, Mr. Bug, then you need the resultant direction as well. So in this case, I'm going that way. So if I was on there for 1 second, where would I end up? Over here.
You would, if you were, wait, what? Can you say that again?
Sure. If I was only on the moving walkway for 1 second,
You would be
then where would I end up?
4 meters that way.
I'd be 4 meters down here, wouldn't I? Yes?
Times 14.24.
Because for 1 second, okay, because what is that? Distance equals, if speed over time, then distance is going to equal speed times time, which is 4 meters per second times 1 second. Seconds factor out, you're left with 4 meters, you're going to be 4 meters downstream.